Okay, all right, here's a couple things we're going to talk about. It's going to be even functions, odd functions, and neither. And they deal with symmetry. And we can have symmetry on a graph about the x-axis, about the y-axis, and about the origin. Okay? So x-axis, y-axis, origin. I'm going to cover the x-axis first because we're not really going to do anything with it. Because here's a parabola that's horizontal, which is what? X equals y squared. So that's symmetric about the x-axis. And I hope everyone knows what symmetry is. Right? It's the mirror image. We can flip it. It's going to be the exact same shape. So we're not going to do much with this. Why? Because this isn't a function, right? It's because I've got an input that has two outputs, and it doesn't pass that vertical line test, right? So that's not a function, but that's symmetry about the x-axis. Okay? Then we have symmetry about the y-axis. All right? And that's something that's got its, like a parabola that has its vertex on the y-axis, right? So y equals x squared is symmetric about the y-axis. I'm going to go into this in more detail. This is an even function. Okay? And we'll see in a bit, an even function is where f of x and negative, well, notice I plug in, 2, I get the same value as negative 2. Okay, that's going to be an even function. Here's a little more detail. Tomorrow's assignment, you need to look at a graph and tell if it's even or odd or neither, and look at an equation to tell if it's an even function, odd function, or neither. Okay, even function, for all x in the domain of f, so all for our whole domain, if f of negative x equals f of x, okay, so if you plug in 2 or negative 2, you're going to get the same answer, okay? So f of negative x equals f of x. Hence that parabola, right? You plug in x and f of x, negative x, f of x, these equal the same amount, right? Okay? So here's an example, going back to this. Okay, so that's an even function. We're in parentheses. F of negative x equals f of x. I'm going to kind of show you two ways. The easiest way really is just plugging in a number. But here is, notice, here's f of x squared plus 3. That's just a parabola that's shifted up. So if you saw that on a graph, home, graph, I'm on the clock here. X squared plus 3. Okay? Notice how that's symmetric. It's just shifted up. The parent function shifted up. That's symmetric. So notice f of x is going to equal f of negative x. Okay? You can look at that graph and know it's symmetric about the y-axis. It should be an even function. Okay? Because of the symmetry. But here we go. Here's x squared plus 3. Notice if I do f, here's f of x equals x squared plus 3. Let's make it f of negative x. Okay, so what's negative? That's basically negative 1 times x. And when they both get squared, what's negative 1 squared? 1, right? And then you're left with x squared plus 3, right? So it ends up being the same thing. So f of x and f of negative x are the same. But it's really easy if you just do what? If you test a number. So here I put in, let's just do 2, function of 2. I plug in 2 for this. 2 squared plus 3 is 4 plus 3 is 7. Now I plug in the negative 2, f of the negative x here. Okay, negative 2 squared is 4 plus 3 is 7. So you get the same answer, even function. Okay? So I think it's probably even easier sometimes just plugging in a number, a 2, and a negative 2. Okay? If it's in the domain. Alright? Now we have symmetry about the origin. And this is a tricky concept. Basically, to get symmetry about the origin, it's, imagine if you could rotate this around, like this is the middle of your propeller. If you rotate this around, this is going to be exactly here, and this is going to be exactly here. Okay? So things that are symmetric about the origin, imagine rotating them about the origin, and would they superimpose on each other, okay? So in this case, this is an odd function, so odd functions are symmetric about the origin. Here's an odd function. This is the cubic function of y equals x cubed. This is our parent function. That's an odd function, okay? This is what an odd function will be. F of negative x equals negative f of x, okay? So if you plug in a negative x, whatever your original function is times negative, okay? So let me give you a little examples of this, okay? Couple examples, go, okay? Here's an odd function, x cubed over 4 minus x squared. And we notice, remember, denominator, this can't be 4, so x can't be plus or minus 2. Alright, so I'm going to plug in f of negative x, okay, into where I would have x, okay? So what's negative x cubed? That'll be negative 1 cubed and x cubed, so that's negative x cubed. And down here I have 4 minus, and in parentheses, negative x squared. And again, we know that's just going to be x squared. The negative 1 squared is 1, and x squared is x squared. Okay? So that didn't change. So notice, f of x is x cubed over 4 minus x squared. And f of negative x ends up being what? Negative f of x. Notice here's f of x times a negative. So negative f of negative x ends up being negative f of x. That's an odd function. Let's do it with numbers. So it makes, maybe it'll sink home. Here's the same function again. I put in, here I put in 3, f of 3. So here's our normal function f of x. 3 cubed, 27, over 4 minus 3 squared is 4 minus 9. That's negative 5. So function of 3 is negative 27 over 5. Okay? Alright, now let's do f of negative x. Negative 3 cubed is negative 27. Again, and negative 3 squared is what? 9. So it's still 4 minus 9. So now it's not 27 over negative 5. It's negative 27 over negative 5. The negatives cancel out. And I've got 27 over 5. So we proved it. This is what? What's f of x? F of x was negative 27 over 5. If it's an odd function, if it's an odd function, f of the negative x is going to be the opposite of f of x. Okay? Here's the f of negative x right here. If that's an odd function, it's going to be negative f of x. And that's what we have here. What's the opposite of negative 27 over 5? Positive 27 over 5. Okay? Alright? So, yeah, f of x was negative 27 over 5. And f of negative x is negative f of x, the opposite of that function, which is going to be a positive. Okay? Here's one where it's neither. Okay? Let me just show you real quick. Escape. Let's go menu, enter, 4, enter. Okay. I want to go control, divide, and let's go, what was it, x cubed? That one. X to the third over 4 minus x squared. Enter. Okay, notice we have asymptotes, like we said, at negative 2 and 2. But notice we can rotate this around the origin. This is like a cubic function here, but this will rotate around this center propeller, and so are these two things here. We could rotate this all the way around and you wouldn't notice anything happen. It's symmetric about the origin, like an odd function. Okay? Alright. Okay, so our next problem is going to be neither even or odd. Here's x squared minus 2x minus 2. And I kind of drew the graph from you. Notice, it's a parabola, but is it symmetric about the y-axis? No. This is over here, this is much different. This isn't going to, if you flip this around, it's going to be looking like, if you reflected this it would be something like this. Okay, so it's not symmetric. So from the graph, you can say this is not symmetric about the y-axis. It's not an even function. Can you rotate this about the origin and get the same thing? No, it's not going to be at all the same shape. Okay, if you rotate that, so it's not symmetric about the origin either. So from the graph, you can't rotate this about that dot there, and it's not symmetric about the y-axis, so it's neither. All right, let's look at, here's x squared minus 2x minus 2. Algebraically, here, I'm going to check for if it's even. I plug in f of negative x. Negative x squared is going to be x squared. What's a negative times a negative, if this is negative, is going to be a positive, so it's going to be plus 2x. And then the minus 2. So notice, this is different. So it's not even. Remember, f of x and f of negative x need to equal each other if it's even, and it's not. So this is not even, okay? And now we're going to check for odd. Remember, if it's these two, f of x needs to equal negative f of x, okay? All right, so I took f of x again, x squared minus 2x minus 2. So what did I do? I'm going to multiply everything here. Let me backtrack here. I'm going to multiply this whole equation by a negative, right? That's what negative f of x would be, right? So I changed the sign of everything. Negative x squared. And I got, this is going to be plus 2x, and this is plus 2. So obviously, these two do not equal each other. So f of x, oh, I'm sorry, let me see. I'm sorry, I'm comparing that to the wrong one, my bad. F of negative, f of negative x needs to equal negative f of x if it's odd, okay? So that's what I need to compare this to. My bad, people. So hopefully you caught that, okay? So negative x, so here, I took this equation, our original equation, made it negative f of x, okay? And changed all the signs, and that needs, negative f of x needs to equal f of negative x if it's an odd function. So here I've got negative x squared, and that's positive x squared, so right away it's not the same equation. And this is plus 2x, that's good, but this is plus 2, that's minus 2. Okay, so it's not odd either, because f of negative x does not equal f negative f of x. Okay? So it's not odd. So that's an equation that's not. You should be able to tell from the graph and the equation. That's what we consider solving algebraically. Okay? And here's with the number. Notice here I plugged in 2. I get 4. 2 squared is 4. 2 times 2 is minus 4. That's going to be 0. Minus 2 is negative 2. Okay? And here, so here's f of x. Here's f of negative x. Okay? 4 plus 4 is 8. Minus 2 is 6. So it's definitely not even. Okay? And now, let's see if I do... now let's try one thing I forgot. I'm glad I caught this again. So let's see if f of x equals negative f of x. So if this was negative f of x, negative would be... Let me change this real quick. Okay? We get negative. I'm going to change the signs of everything. Okay? So again, let's plug in the negative 2. That's 4 minus 4 plus 2, and that's going to be a positive 2. So none of these things, so again, f, guys, I'm going brain dead here, guys, sorry. So f of negative, if this was an odd function, f of negative x needs to equal negative f of x. And f of negative x right here is 6. Here's negative f of x is 2. So it can kind of get confusing. Here's negative f of x with my corrections, that's 2. Here's f of negative x, they do not equal each other. Okay, and also f of x and f of negative x don't equal each other. Okay, so they're all different. So it's neither of them. Okay, so that's pretty much the lesson. All you got to do is go through and figure those out. And you can tell by the graph or by doing this. Okay, all right. Hopefully that wasn't too long. Did I keep it under 15? Oh, hey Mariah, go.
Oh, I don't know what to do now, so never mind.
Who wants to say goodbye?
I do, actually.
Goodbye.
14 minutes, hurry.
Bye.
All right. All right.